Hi, today we from Group 2, Section 2 would like to present our machine, which is a CNC Turning Center with a gantry loader for our workpiece handling. So what type of CNC is a CNC Turning Center with a gantry loader? It's a normal lathe CNC machine, but it's equipped with a gantry loader. So the gantry loader is designed to remove common barriers to automated parts loading for CNC lathe. Basically, it's like a claw which handle the changeover of a workpiece every time. So the function of a CNC turning center with a gantry loader is it helps to manage the changeover of the workpiece faster than normal. It is a lot simpler than using robotic, which is too complicated, expensive, and requiring too much time. It is run automatically and unattended since the operator does not need to load the workpiece every time, which saves times and very efficient compared to a normal CNC turning machine.
Lathe is a two-axis machine, X-axis and Z-axis that generally has one spindle. CNC Turning Center are computer controlled and can have 3, 4 or 5 axes with more versatile capabilities application such as turning, drilling, tapping, milling, and Y-axis as well. In Y-axis plane, tools can move in a plus or minus direction perpendicular to Z-axis and spindle center line. This Y-axis motion is toward or away from the door of machine, while X-axis motion is floor to ceiling. The CNC turning center with gantry loader is horizontal turning center. With this type of turning center, gravity pulls the chip away from the workpiece and need a gantry to load the part.
Today I will talk about the main components of the CNC turning machine. The first main component is the headstock. There are many parts to the headstock, and this is where many of the functional pieces of the machine reside. Here you will find the main spindle, the change gears, and the speed change mechanism. You will also find the chuck, which is mounted in the front of the spindle. Next is the bed. The lathe bed is a base connected to the headstock, such that the carriage and the tailstock move in parallel with spindle axis. The movement is facilitated by bedways which restrain the carriage and the tailstock in a set track. Here is the example of a CNC lathe machine, which the headstock covers are removed, so you could see the main drive, the gears, and also the bed. Next is the chuck. A chuck is a specialized type of clamp used to hold an object with radial symmetry, especially a cylinder. There are two types of chuck that is usually used or present in the CNC machine, which is the 3-jaw chuck and the 4-jaw chuck. The main difference between the 3-jaw chuck and a 4-jaw chuck is that the 3-jaw chuck is universally and only used to hold round and hexagonal workpieces, while the 4-jaw chuck is used to hold wound, square, hexagonal, and irregular shape of workpieces. Next is the carriage. The carriage holds the cutting tool and moves it longitudinally to the workpiece for the turning operations or perpendicularly for facing operations. The carriage is composed of two castings, the top, the saddle, and the side or apron. Last but not least is the tailstock. The tailstock refers to the center mount, which is positioned opposite to the headstock. In contrast to the headstock, the spindle in the tailstock, which can include a taper to hold the drill bits, centers, or other tooling, does not rotate. Instead, it travels longitudinally under the action of a lead screw. Tailstock are mostly used to give an extra gripping force for component machining. For long component machining, they provide extra force on the other end so machining process can complete smoothly.
So for the next point is limitation of the CNC machine to manufacture a product. The first limitation is relatively high startup cost. In CNC machining, startup costs are mainly connected to process planning. This step required manual input from an expert. So startup costs are usually relatively high when compared, for example, to 3D printing, where process planning is highly automated. They are still much lower than formative manufacturing processes, which are injection molding or investment casting, which require the preparation of custom tooling. It is important to keep in mind that startup costs are fixed. One of the benefits of hand production is the ability of a machinist to move around a large part. For some CNC machining projects, the measurement of the part you have machined may have limitation. Travel distance typically have measurement along the X, Y, and Z axis. However, some machines may operate on 4 or 5 axes, adding more dimension that the machine can work on at one time. Even if the part size fit into the working area, large compartments have other issues that make CNC machining difficult to use. The size of the part may impact the accuracy of the tool working on it. Extra weight put additional stress on the material, increasing the chances of distortion. To complete manufacturing process, the machine may require special setup or operating training to ensure the tool having the correct starting position relative to the design and part size. The operator has a significant level of control over the accuracy of a CNC machining project. While operator error can cause problems with the accuracy of the machine part of the program used to create it, you can do something to avoid this issue. For example, look for a company that acknowledges and learns from its mistake. While CNC machining has a lower chance for human error than manual part creation, mistakes can happen. The company should correct the error and change procedure based on what they experience taught its worker.